So let's move on to the next video. In the previous video, we took care about these variables and showed descriptive statistics for them. And we also added control variables that are not shown in this picture, but it's the research model, and control variables are not depicted in the research model usually. So now we have to understand what we do with the BIS and BUS scale. Let's have a look at our data, how it looks like. We have the BIS scale. These are the items for the BIS scale, and we have the BUS scale. And within the BUS scale, behavior activation scale, we have three different, I think it should be four, but probably in this data collection we made only three different subscales. The RR, let's try to remember what it was. We'll try to find it. Was Carver, and White, BIS BUS scale. Let's start the paper. And they said there are sub-dimensions. Probably I just, in this data set, we didn't collect all of them, or we did, no, actually all four. So we have the BIS scale, then we have the BUS. RR stands for reward responsiveness, D stands for drive, and F for fun seeking. So that's why we have the BUS RR, BUS D, and BUS FF. The question is what we do with these variables, because there are many items that actually measure the same thing, that all these 7 questions, they measure the behavioral inhibition, how we proceed with them. In this event, we talk about the latent construct. It is latent, it means there is something we cannot observe and directly measure. That is why we need to approximate this latent construct by measuring different aspects of it, asking about like being happy. You can ask people whether you're happy or not, but you can also be less precise and say, are you satisfied with your work? How about your family? Are you satisfied with your family? Are you happy when you go to work? Are you feeling good if you spend time with your friends and neighbors and so on? And overall, if you measure all different aspects of a person's life, you will understand the level of happiness of this person in different aspects. The same happens here. The question is how we work with them. And we have two options. If this scale is developed new, then you have to run confirmatory factor, exploratory factor analysis, and confirmatory factor analysis, which we are not going to run because it's not a part of this video. Of course, if you write in comment section that you would like to know it, I can record a video for you. Otherwise, I recommend you watching the videos by James Gaskin. He made a great structure equation modeling playlist, and I think the one from 2016 is the one where he starts with SPSS and explains how you make all the other tests, what you need to show that your skills are good. For now, we have to do at least two things. First of all, we need to show that the items are internally consistent. So it means they have high Cronbach alpha or low Cronbach alpha. You can also calculate composite reliability, but it is not part of SPSS, so we have to do it with a different tool, or you have to do it manually. We will not do it. We focus on the Cronbach alpha. And we have to show the cross-loadings, that the items measure what they have to measure and don't measure something else. And we start actually with this second one. So we want to know that this BUS RR scale measured RR and didn't measure D, or didn't measure behavioral inhibition. How you do it? I'll show you how I do it, and we'll just see how it really works. So first of all, we go to dimension reduction. Why dimension reduction? Because we can say that with these 7 questions on BIS, we measured one dimension, that was behavioral inhibition. And with these 4 questions, or 5 questions, we measured behavior activation, reward responsiveness, I think, and so on. So we need to kind of reduce the dimension, say, okay, go from these 7 items to only 1. That's why it's called dimension reduction. Colon factor. And now we need to add all these questions for the analysis here. What SPSS is going to do now, we're going to make some additional commands for it. So first of all, let's make it look nice. No, I don't want to have variable information. I want to have variable names. Okay, now it looks a bit easier to read. And we can see whether SPSS will see that the items correlate with each other, but not with items from another latent construct. That's why we go to extraction, and by extraction we go for, there are different options. If you work with SPSS, continue working there. Principal component analysis is fine. If you work with AMOS and structure equation modeling, then you should go for maximum likelihood. There are different procedures, and SPSS AMOS works with maximum likelihood. That's why it's better to start also here correctly, but we make principal component analysis. Then we need to see, based on eigenvalues, means it will try to see how many items will be calculated from the statistic, but you can say also, oh, I have 4 items, please, it should be 4. If not, you just say, try to see how many you will find. Then we go to rotation. It's a more tricky one that I'm bad in explaining, but we can assume that some questions, they should correlate because you are measuring something very related. And in this event, I think you have to click Promax. If you assume that items should not correlate, the questions that you're asking, you should call Varimax. And what I've learned direct oblimin is something where you take, if you assume that items might correlate, but it's a kind of combining both of the procedures. If you want to know more about direct oblimin rotation, you can go to the Gaskin Nation website, the one from James Gaskin, and there is a nice clean description when you apply the direct oblimin rotation. I usually use the direct oblimin because the explanation that was provided there is exactly fits my needs. Then we go to scores. In scores, we don't click anything. We'll need it later. If you click here on save, the factors will be saved, but we don't know how they look like. That's why I wouldn't save them now. And by the options, we need to don't click sort by size because they are sorted by name. It makes no sense to sort them by size, but we want to suppress small coefficients of 0.3. We'll do it now without suppressing coefficients, then I do it with, that you will see that you can see the difference. And click on OK, and the SPSS will try to look into variables and see which of them correlate and which do not correlate. And it says we have 4 factors that actually we had to have 4, but which of them are they? And we go to the pattern matrix. And now you can see already that these items are highly correlated with each other up to here. Look at it, 0.8, 0.8, 0.8, but with the others is a very low number. So if it is below 0.3, we can neglect it. And these tables are kind of hard to read. Some scholars provide this table, but you can make it a bit simpler. We go to the same analysis, and in options we say, please don't show the coefficients if they are lower than 0.3. It will make the reading a bit easier. Click on OK. Now we have the same test, but now it shows us only, we go to pattern matrix, that the items really correlate. Let's look at this one. These 7 questions are exactly behavioral inhibition scale, and they're all highly correlated. The loadings, this is called the factor loading. This is called the factor, or your dimension, or your latent construct. And this is the loading in how much this item loads on this factor. The higher the loading, the better. If the loading is before 0.7, it's a kind of problematic. Below 0.6 is not acceptable. So above 0.6, like here, it is acceptable. And as you see, they load on the first factor, but on none of the other factors, at least to a very low extent, so lower than 0.3. The second is here. As you see, also all items are well loading on one factor and not cross-loading on other factors. And here we have the items that also have high loadings, higher than 0.8. Just ignore the negative numbers for now. And here also the same. So we see we have the very clear matrix of the factors. Why it is important? Because as you remember in the first video, I told you that we have changed the questions, and that's why after changing can happen that all of a sudden people will understand them as something completely different. And this test would show us that, for instance, this item would have moved to a different factor, that the meaning of the item has changed, but it doesn't seem to be the case. One more thing that I want to pay your attention to. So first one, look at these 2 negative items within a positive factor. The reason is very simple, because I'm going to show you on the data. Look at the name of the item. They are reversed, item number 5 and item number 7. Let's look at them one more time. It is exactly 7 and 5, the 2 items. Reversely coded means that you can ask people how happy they are, but you can also ask people how unhappy they are. It is the same question, but formulated in a negative way. Some scholars recommend to introduce this reversely coded question just to make people switch between different options and really read the questions. Some people think it is confusing participants, that's why I do not introduce reversely coded items. In this questionnaire, it seems that the authors had reversely coded items within one construct. If it's all negative, it's no worries, just factors are negatively correlated. So what we can take from it for our analysis. First of all, you have the cross-correlation table. You can show what are the questions and what are the loadings on this on each of the questions. So this is the cross-loading section. This is exactly what it shows. It shows us that the items that measure behavioral inhibition scale, they measure it and do not co-measure something else. This is one of the simple tests for the discriminant validity and convergent validity. So they converge on one factor and they do not load on other factors. And the same with items here, the same with items here. So we can just take this table, copy paste it, and show what are the loadings. And I think for here, you can even ignore the negative numbers here and here. But here you have to retain them because they're within one factor. Then you can see that it was negatively formulated item, but within the same factor. Then we have also the cross correlation, the structure matrix, more or less. I don't know exactly what is the difference. And here is the correlation of the factors among each other. So the cross correlation of factors, the whole dimensions together. The bis dimension correlates with bis dimension perfectly. It is the same. And bis dimension with a bus RR scale correlates to minus 0.26. So it shows that the items go slightly in different direction, and very hard negative with the item with a dimension 3, which is BIS, Behavioral Activation Scale Drive, and so on. So this is additional component correlation matrix that you can also provide in your analysis. But now we need to do a few more things. First thing that we need to do, we know now the cross loadings and item loadings. This is, by the way, the exploratory factor analysis, that's what we started with. And now we need to calculate the internal consistency, which is the Cronbach alpha. And I'm going now to show you what we forgot to do in a very simple manner. We go to scale, reliability analysis, because it is reliability analysis, how internally consistent and thus reliable the item or the factor is. We go to reliability analysis, and we have to do it for all factors separately. So display variable names. And the first one is behavioral inhibition scale. And the Cronbach's alpha should be higher than, so ideally, the higher the better. So 0.9 or higher is just perfect. 0.8 and higher is very good. 0.7 higher is good. 0.6 and higher is a kind of acceptable. Go to statistics. We want to see a statistic for scale if item deleted. The reason is, if you have many items, many questions, sometimes you are allowed to delete some of them. As the construct is complex, latent, you can measure it with 10 different questions. If one of them is wrong, you can delete one. The other 9 are still measuring the item. That's why you're allowed to delete some items. The rule of thumb says that there should be at least 3 questions for each factor. That's why up to 3 you can delete them. And which one you should delete, and this statistic will show you which one is ready to be deleted. And let's do the analysis, and it's a terrible Cronbach alpha. It's just terrible. And the reason is very simple, because we forgot something. We forgot that these items, BIS 7, are inversely coded. So they are negatively related to other things. And Cronbach alpha doesn't know that they are inversely coded. Cronbach alpha test thinks that these items are measuring something wrong. That is why these 2 items, as you see, they are loading good, but Cronbach alpha is bad. We have to recode them. That's why we go to this test. We go recode into different variable, so just repetition, or you can go to transform, recode in different variable, and we take the item number 5, the item number 7. We call them BIS recoded. Let's call positive, just to be known. BIS 5 recorded positive. Change, and this variable we will call BIS 7 recorded positive. BIS 7 recorded positive. So what it means to recode, change all the new values. Actually, reversely means we had a 1 to 4, so 1 should become a 4. 2 should become a 3. 3 should become a 2, and 4 should become a 1. You see, 1 will be 4, 2 will be 3, 3 will be 2, 4 will be 1. Click on continue and click on OK. So now we have the 2 new variables. Let's see where they are. They are here at the end. We take these 2 variables and move them to where they have to be. And we take the 5 and 7 initial, reversed, and put them away, just they do not disturb us. Let's put them somewhere here. And now let's repeat the reliability test. So now we delete this item and we delete that item, and instead of them we add the items, the newly coded BIS 5 and BIS 7. Let's position them where they do look nice. So 1, 2, 3, 4, 5, 6, 7. Click on OK, and a miracle occurred. We have the Cronbach alpha 0.919, which is just perfect. Now we repeat the same test. We don't need to delete anything. I just want to show you this is scale if item deleted. And if we delete this item, it will become worse. If we delete this item, it will become also worse. Look at this, 919. If I delete, it will become 908. 915, so whatever we delete, it will become worse. That's why we have the perfect factor. Let's do the same reliability analysis for other items. Bus R. And we have again the very good Cronbach alpha, 0.82. Now let's go to reliability analysis for the BIS D. And it again will be perfect, 0.8, almost perfect. And the last one is the BIS scale FF, fun seeking. And it is good, 7.97, almost 8, so it's good, very good, actually very good. So you have now the internal consistency items that you can report. You can say that in my newly adopted questionnaire, after adoption, I still have high internal consistency of Cronbach alpha of 797 for the fun seeking and 892 for whatever it was, drive or whatever. So you have now the internal consistency items, and you have now the cross-loading table that you can show. The last thing that left to us is actually how can I work with the variable scale, but we'll do it in the next video with the scales, because we have now several items, but you need to work with only one scale. This is what we're going to discuss in the next video.